Welcome to next lesson in conservation of energy and momentum. Here in this class we will discuss some of the numerical problems and solutions of this chapter. The first problem is a 50 kilogram man standing on a surface of negligible friction kicks forward a 25-gram stone horizontally so that it gets a speed of 2 meters per second. What velocity does the man acquire? So here a man of mass 50 kilogram kicks a body of mass 25 gram, that is a stone, and it is given that the surface is of having negligible friction. So we have not to consider the friction. It is a frictionless surface. So in the absence of friction, this man plus stone, when taken as a system, the net external force acting on the system is zero. So the total linear momentum of the system should be a constant. So by the law of conservation of linear momentum, the total linear momentum before the kicking is zero because the man is at rest and the stone was also at rest. Then after kicking, the stone gets a velocity of 2 meters per second and man gets a velocity, and that velocity is to be found. So we assume that small m is the mass of the stone, small v is the mass of velocity of stone, and capital M and capital V are the mass and velocity of the man. And by the law of conservation of linear momentum after kicking, that is mv plus mv, is equal to momentum before kicking, that is equal to 0. That is, a man at rest kicks the stone which is initially at rest. So we get the velocity of the man, capital V is equal to, from here V is equal to minus small mv by capital M, that is equal to minus of, so small m is 25 gram, that is 0.025 kilogram, into velocity v is 2 meters per second, 2 divided by capital M is the mass of the man, it is 50 kilogram, that is by 50, that is equal to minus 0.001 meter per second. So here the negative sign shows that the velocity acquired by the man is opposite to the velocity acquired by the stone. This is similar to the recoiling of gun during the firing of a bullet. The second problem is an object of mass 2 kg moving with a velocity of 12 km per second explodes in the atmosphere into two pieces, and they move along the same path with speed 15 km per second and 11 km per second velocities. Find the mass of each piece and energy released in explosion. The solution is, before explosion, capital M is equal to 2 kg. And capital V, that is the velocity of that single object, it is equal to 12 km per second, that is equal to 12,000 meters per second. After the explosion, the velocity of one fragment, it is equal to 15 km per second, that is equal to 15,000 meters per second. Then the velocity of the second fragment is 11 km per second or 11,000 meters per second. We have asked what is M1 and M2, and another one is what is the energy released in explosion. We will calculate here, I will calculate only M1 and M2, and the second part is left as an exercise. So we have the total mass here, M1 plus M2. M1 is the mass of the fragment, that is, it will split into two pieces. One piece is having mass M1, the second piece is having mass M2. So total mass after the explosion is equal to total mass before the explosion, that is M1 plus M2 is equal to M, that is equal to 2 kg. Therefore M1 plus M2 is equal to 2, that is some equation number 1. Now, as all the velocities are in the same direction, because the question gives that after explosion the two pieces and they move along the same path, that is along the same path of the initial object. So here capital V, V1 and V2 are all in the same direction. So by the conservation of angular linear momentum, we have capital MV, that is momentum before explosion, is equal to M1 V1, that is the momentum of the first fragment after explosion, plus M2 V2, that is momentum of the second piece after explosion. That is M is equal to 2, V is equal to 12,000, is equal to M1 is unknown, M1 into V1 15,000, then M2 V2 is 11,000. So dividing by 1000 we get 15 M1 plus 11 M2 is equal to 24. That is equation number 2. Now subtracting equation 1 from 2 by first initially multiplying 1 by 11, we get here it is 15 M1 here M1, 11 M2 here M2. So we can eliminate M2 by multiplying equation 1 by 11 and subtracting that result from equation 2. So that is equation 2 minus 11 into equation 1, that is equal to equation 2 is 15 M1 minus 11 into M1 plus 11 M2 minus 11 M2, that is equal to 0. Then 24 minus 11 into 2. Therefore 15 M1 minus 11 M1 is 4 M1 is equal to 24 minus, this will be 22. 24 minus 22 is 2. Therefore M1 is equal to 2 by 4, that is equal to 0.5 kilogram. Now M2 is equal to, from equation 1, M2 is equal to M minus M1, that is equal to 2 minus M1, that is equal to 1.5 kilogram. Now the disintegration energy, the energy liberated in this process, it is not calculated here. It can also be calculated by using the kinetic energy before explosion and kinetic energy after explosion. Before explosion kinetic energy is half capital M into capital V square. We will get some value. And after explosion kinetic energy is half M1 V1 square plus half M2 V2 square. And we can see that the kinetic energy after explosion will be less than the kinetic energy before explosion. So that difference in energy is converted into another form, that is the energy released during the explosion. That is left as an exercise for you. Now the third question is, 3 particles of masses 7 gram, 4 gram and 10 gram are located at positions 1, 5, minus 3, that is x, y, z coordinates meter, then 2, 5, minus 7 meter, then 3, 3, minus 1 meter respectively. Find the position vector of their center of mass. It is given that masses are M1, M2 and M3. Then positions are R1, R2 and R3. The total mass is M is equal to M1 plus M2 plus M3, that is equal to 7 plus 4, 11 plus 10, 21. Now if R is the position of center of mass, we have Mr is equal to M1 R1 plus M2 R2. Therefore the position of center of mass R is equal to M1 R1 plus M2 R2 plus M3 R3 by M. That is M1 is 7 into R1 is 1, 5 minus 3, then M2 4, 2, 5 minus 7, then M3 10, R3 3, 3 minus 1 by capital M is total mass 21. That is equal to, multiplying this result we get 7 into 1 7 plus 4 into 2 8, 8 plus 7 is 15, 15 plus 10 into 3 30, 30 plus 50 45. So we get 45, similarly 85 minus 59 by 21. Now 45 by, that is equal to 45 by 21, 85 by 21 minus 59 by 21. Also in this problem we see that the given quantities are in gram. It is 7 for 10 gram. I have not converted that gram into kilogram because in the numerator there is M1, M2, M3 and in the denominator there is capital M. So gram and gram gets cancelled. Even if you convert gram into kilogram, there will be 10 raised to minus 3 in numerator and 10 raised to minus 3 in denominator. So the result will be same. If the quantity appears both in numerator and denominator, then we need not convert the quantity into SI system. So that is the position vector of the center of mass is 15 by 7, 85 by 21 minus 59 by 21 meter. Now the fourth question, an empty rocket of mass 5000 kg contains 4000 kg of fuel. If exhaust of fuel is 2 km per second, exhaust means the exhaust speed of the gas. Calculate the maximum velocity attained by the rocket. And the maximum velocity attained by the rocket V equal to V0 plus small v into ln of m0 by m. Here the initial speed V0 is equal to 0. The exhaust speed small v is equal to 2 km per second. Initial mass of the rocket is equal to total mass of the fuel plus mass of the empty rocket, because initially the rocket is fully fueled, therefore it is 45,000 kg. Final mass m, it is the mass of empty rocket, because the complete fuel is already burned out, therefore final mass is equal to 5,000 kg. So the velocity acquired is equal to 0 plus 2 into ln of 45,000 by 5,000, that is equal to 2 into ln 9. ln means log to the base e, that is equal to 4.39 km per second. Here also you can see the small v is 2 km per second and we get capital V in km per second. I am not converting this 2 into meter per second, so the answer is again km per second. And the fifth one, the maximum and minimum distances of a comet from the sun are 2 into 10 raised to 12 meter and 8 into 10 raised to 10 meter respectively. If the speed of the comet at the nearest point is 60 km per second, calculate the speed at the farthest point. Now if R1 is the distance of the closest point, it is given as 8 into 10 raised to 10 meter. V1 is the velocity at the closest point, it is given as 60 km per second. R2 is the distance of farthest point, given as 2 into 10 raised to 12 meter. And V2 is the velocity at the farthest point that is to be discovered. Now by the conservation of angular momentum, m1 r1 v1 is equal to m2 r2 v2, because mv is the linear momentum and mrv is the angular momentum. Or we get r1 v1 is equal to r2 v2, or v2 is equal to r1 v1 by r2, that is equal to r1 into v1 by r2, that is equal to 2.4 km per second. Here also I am not converting this v1 into meter per second. 60 is the kilometer per second and we will get the answer in kilometer per second. This is because here we are getting v2 in terms of v1. If v1 is in meter per second, we get v2 also in meter per second. Now here v1 is in kilometer per second, therefore we get v2 also kilometer per second. Now velocity at the closest position is equal to 2.4 km per second. So there are many problems in your textbook. Do it, and if you have any doubt, ask the questions. Thank you for watching this video.